Hello everyone, welcome back to the channel. Today we'll take a look at a Kubernetes live demo. I understand that there are a lot of Kubernetes demos out there on YouTube, but what we'll try to do is a really practical one. We'll use a very simple Python application that I'll show you. I'll write it by myself, and then what we'll do is we'll create a Docker file, then we build a Docker image, we'll create a container out of it, and then we'll try to understand how uh, Kubernetes is beneficial. Then Docker will try to put that on Kubernetes. Then we'll see how a deployment is created, what is the advantage of a deployment. Then we'll talk about Kubernetes service and services types, and we'll also take a look at how do they expose this application that is deployed on Kubernetes to external world. Perfect. So this is going to be a really interesting one, and I'll try to keep it as simple, short, and sweet. Without any delay, let's quickly jump on to the video. Let's quickly jump onto the demo. So perfect. I have got a Kubernetes cluster. So it's very easy to install a Kubernetes cluster if you're on Linux or Mac operating system. If you're on Windows, you might find it slightly difficult. It's not too difficult, but still, the problem with Mac as well as Windows is that it doesn't support Kubernetes natively, but you need to install a virtual machine, and on top of it you have to install Kubernetes. But at least for Mac, you can simply install the virtual machine with basic commands. For Windows, you might have to face issues sometimes. So I got a Minikube cluster. If you want to know how do we install it, it's very easy. You can go to the Minikube official documentation or any other distribution of Kubernetes. You can take K3s, K3D, anything, the one that you would prefer. If you want to know more about it, you can watch my previous video on Kubernetes distributions and their comparisons. I'll also put that in the description. Okay, so if you see here, let me check the status of Minikube. So I've got the Minikube cluster running. It is just created on a HyperKit virtual machine, and Minikube cluster is there. So now what I'll do is let's start writing a simple HTML file. So for which we'll take example from W3 schools. So W3 schools HTML, right? So this would be a very easy one. So I'll just copy any HTML file that is there, right? And I'll go back to the terminal. Let's add this here. So Vim. So what I'm trying to do is I'm trying to build an application. So this is the HTML file, and so we'll slightly modify it. We'll call it K8s Demo. I could have done this previously before the video, but I wanted to show you in live, right? I'll call this YouTube Abhishek.Veeramalla. This will be heading of my HTML page, and let's call this as version V1, right? So this would be a simple HTML page, right? And what I'll try to do is let's write a Python application, and this Python application should host this HTML file and be executed on your local host. So before writing a Dockerfile, I'll show you how that happens. So this is a very simple Python command. If you have Python installed on your machine, you can simply run this command, python -m http server followed by, let's say, port 6100, right? So once you do this, basically Python opens a port on your, let me increase the font of my browser. Okay, I hope it looks good. So I can simply come here and say http localhost. The port number is, what was that? 6100, I guess. Right, so it says YouTube Abhishek.Veeramalla version V1. So this is my basic application that I've written. Okay, and now let's try to put this in a Docker file and build a Docker image out of it. So for which what I'll do is I'll write a Docker file. I hope that will also help you out in writing simple Docker files. I mean, if you're not aware of how to write a Docker file, it's very easy. Use a from statement, take a base image. For now, I'm taking Python as a base image so that I don't have to use any other installations, or I don't have to install any other libraries. So because I have Python already installed, now what I can simply do is I can copy the index.html file that we just wrote into this Docker file. Now I got the index.html as well onto this one. So now what I can simply do is I can execute this as part of the CMD, the command that we have executed. Let's simply call Python, let's say -m, and then followed by http dot server followed by 6100. So before I do that, I need to expose this port in the container as well. Okay, so I have exposed this in the container. Now let us build this Docker image. So for which what we need to do, simply come here and say docker build dot, because there is only one Docker file here on the disk or on the folder that I am in. It will not take much time. It will be built very soon, like in a fraction of seconds, because it's a very basic Docker image. So once I have this, now let's try to run this one and see if it is getting executed on a Docker image. So simply do Docker images, right? You can also take a look at the SHA here, but if you want, you can also take from here. Then Docker run -it followed by the image. But before we do that, we should also expose the port on the host, right? So we'll do that as well. So now your Docker image got executed, and let us see, because we stopped the Python program, it shouldn't run, but now it still keeps running because we got the Docker running, and the port is also exposed onto the virtual machine. So this is a very basic Docker application that I've hosted in a Docker image. Now let's quickly push this image. Okay, so I'll tag this image as docker.io Abhishek. This is my Docker repo. This is a Docker registry. This is my Docker repo. And then let me call this image as basic K8s Demo version 1. Okay. So as soon as the image is tagged, what we can do is that we can simply copy this one, and we can do Docker push to my Docker hub. I already logged into Docker hub. Even you can use any other registries like Quay or something else, whatever you would like to. So perfect. It will not take much time again because this is a very basic image. So yeah, let's give it 1 minute for it to be pushed. Okay, awesome. So the image is also pushed. Now, if we go to the Docker hub and try to find this image, you can see this image on the Docker hub, but this is not our goal. So now your question might be, because we are able to do everything with Docker, right? I'm able to install a Docker container. I'm able to create a Docker container, and I'm able to host my application. But the real problem with Docker is, like, Docker is not an enterprise solution. If you want an enterprise solution, you should either go for Docker Swarm or Kubernetes, because it's just a container. There is no orchestration, there is no scaling, there is no high availability. If you want to know more about it, like, you can use a simple Google search to understand difference between Docker or Kubernetes, or you can watch videos on my channel. There are previous videos which explains the differences between Docker and Kubernetes. So my real intention is to move to Kubernetes. So for that, what I have to do is either I can create a Kubernetes pod, but instead, what I'll do is that I'll create a Kubernetes deployment. Okay, the reason why we will do Kubernetes deployment is because a pod is simply a Kubernetes smallest unit of deployment. It is mostly similar to a container, but it has some additional advantages. Like, if you have multiple containers inside the same pod, they can basically communicate each other with a local host. And there are other advantages as well. But the reason why we will do a Kubernetes deployment is that Kubernetes deployment is basically a Kubernetes controller which maintains the state of your Kubernetes pod. So let's say accidentally your Kubernetes pod got deleted, or somebody has tried to gain access to your Kubernetes pod and made modifications to it. So your Kubernetes deployment takes care of keeping the state of your Kubernetes pod. So it's the basic behavior of any Kubernetes controller. So that's why what we'll do, and we'll go ahead and write a Kubernetes deployment file for the image that we created, right? So I don't remember the Kubernetes deployment manifest, and nobody should actually remember it, because it really does not make any sense. You can simply go to the Kubernetes documents, and you can simply copy it from here, because there's no real point in remembering the whole manifest. You should at least know what each and every field here does, but you don't have to remember this. So firstly, let's start from top down. So the kind is deployment, and then I have labels here. Label is basically the metadata information which is used to identify, like if somebody wants to know which deployment is this. So let's say basic K8s demo. Okay. And a label is very important because, a label uh, is one of the main reasons, or is one of the um, important ways of how Kubernetes identifies the applications, and how you can make use of selectors to manage the labels or manage applications using labels. I'll talk about labels and selectors once we move down to the pod section. But for now, just create a label for your application and call it the same thing, basic K8s demo. Now, I just need one replica. Replica is nothing but how many pods you want for this deployment. I just need a single pod. And okay, from here on, this is really important. Try to focus here. So this is your deployment information, the kind is deployment and the metadata. From everything that goes into the Kubernetes spec is about your Kubernetes pod. So firstly, I just want one replica. And after that, the selector is basically very useful to identify the pod by a deployment. Like I told you, Kubernetes deployment, it maintains the state of your Kubernetes pod. But how does a Kubernetes deployment identify your Kubernetes pod, right? There should be some mechanism. And names are pretty common thing, right? Let's say my name is Abhishek. There can be another person with the same name, Abhishek. So if deployment tries to take control of everybody with the name of Abhishek, that really does not make sense. You just want deployment to take control or to maintain state of pod that it is intended. So that's why instead of using names, what we make use is the concept of labels and selectors. So for the pod here, what we'll do is that we'll give a name called app demo, for example. So you have to give the same selector here. So that's how deployment identifies a pod. After which, you need to sorry, what did I tag it? So Docker images, I don't remember the tag. Yep, I got it here. So this would be my image that we just pushed. So let's use the same thing. If you don't give docker.io, by default it would take docker.io, but just to be sure here, let's call this, and my bad, sorry, this should be the image, and the other one should be just the name, which you can give anything, but the image should be the one that we just pushed. So here what I'll do is I'll call this as K8s app demo. Okay, now the container port. What was the container port that we used in the Docker file? We need to use the same thing. What is that? 6100. So now once you do this, go ahead and say kubectl apply -f followed by deploy.yaml. So what actually happens with this command? So kubectl is your Kubernetes command line, or is it's your command line interface. So using kubectl, basically, firstly, you need to let your kubectl know which Kubernetes cluster you are referencing. Okay, which I have already done. And when you install Minikube on your local, basically your kubectl will point to your Minikube. But if you have multiple Kubernetes clusters, that's a different topic where you have to use the Kubernetes config to manage multiple Kubernetes clusters, or you have external tools to do it. But for now, let's just focus on this specific cluster, that is Minikube. So kubectl apply -f deploy.yaml. So once you do this, what happens is your Kubernetes deployment along with your pod gets created. So say kubectl deploy, you'll see that your Kubernetes is getting your deployment is getting created and followed by the pod that is getting ready. So if you see, the availability is 0, and the pods that are getting ready is 0 out of 1. So you can also see this by using pods. So because the pod is ready, if you go to the kubectl to get deploy, again it will show you that the number of availability of pods is 1, and the pods that are in ready state is also 1. Now let's quickly see kubectl get pods -o wide. Okay, so -o wide basically gives you the complete information of your pod, where I can get the IP address of my Kubernetes pod, right? So now the problem here is that when we created a Docker container, okay, so we noticed that I did a port mapping, right? For me to access the application from my laptop or from outside of your Kubernetes, Docker container, you have to do a port mapping. We will see how to do that with Kubernetes as well. But main problem is that, like I told you, a Kubernetes pod is as similar as your Docker container with some additional advantages. So what happens is that if you share this IP address, I understand that you deployed your Docker container in a Kubernetes cluster, and you say that Kubernetes, I just told you that Kubernetes has a auto scaling capability, scaling capability using Kubernetes deployment. But the problem here is that every time your Kubernetes pod gets recreated, like let's say, let me delete this pod. Okay, kubectl delete pod followed by the pod name. So if you see here, I'm deleting it. As soon as it gets deleted, or before it actually gets deleted, Kubernetes creates a new pod. But when the pod comes up, the IP address changes. So let's give it a second and I'll show you live. So if you wait for a second, the pod comes up with a different IP address. And the problem will be if you share this pod information to either your testing team or persons who are testing this application on your development cluster, they'll try to access with the same IP address. But when the pod is restarted for some random reasons, you see the IP address is changed. So let's say you shared it with a development team members in that the IP address is 172.170.5 and ask them to test it on a cluster because you just deployed it as a DevOps engineer. So what they'll do is that they'll log into the cluster and they'll try to access the application using curl command. My bad. And they'll say that the application is working. But when you share it with your client or when you share it with other people, probably your container might be restarted and your deployment might be, sorry, your pod might be restarted and the IP address is changed. So to avoid such problems, we actually need a proper solution, or we need a proxy that basically does the service identification. Okay. So for that, what we do is that in Kubernetes, we create a Kubernetes service. And basically, we'll ask users to talk to Kubernetes service, and service will continuously monitor, the Kubernetes pods and using the labels and selectors concept again. And it understands that, this is the IP address of the newly created pod or the available pod. And it then cascades the request from you. I mean, service takes the request from you and sends it to the appropriate pod IP address. So let's try to see this practically again. Now, what I'll try to do is I'll try to create a service for the same. Okay. So for which, again, I don't remember the service manifest. So I'll go back to the Kubernetes documentation and I'll simply say Kubernetes service. And you'll get a documentation for your Kubernetes service. You don't have to remember all of these things because they really do not add any value. If you remember this YAML manifest, all that you need to remember is what each and every field in the manifest does. Now, again, let's call this K8s app demo or demo app, whatever you would like to. The important part, like I told you previously, lies in the labels and selector. So you need to give the same label that we gave for the deployment. I remember we gave it as demo app. So that's why what I'll do is I'll give the same selector in the service, and target port is, what is the target port that we have given? Target port is 6100 and service port is 80. You can give any other port, it does not matter. So as soon as we create this service now, kubectl apply -f service.yaml. Okay, so now let's give it a second for the service to be created. Kubectl get svc. Okay, so the service is created, the one that we gave, and the cluster IP is this one. Now let's try to access the service using, the pod using the service IP address, or the application using the service IP address. Minikube SSH to just log into my Kubernetes cluster, and I'll say curl followed by this one. Okay. Now, if you see carefully, sorry, what has happened? Let me see. What is happening? Just a second. Okay, so basically we did a classic mistake. That is, we basically provided wrong labels and selectors. So for which, just go to the deployment that we created, and I realized that this is the name that we have given, app basic K8s demo. So we'll do the same thing. Let's go back to the service, kubectl edit svc, and let's go back to the actual service that we created, right? Okay, so this is the service that we have created, and what I'll try to do is I'll try to replace the labels and selector. Where is the selector here? If you're not comfortable with kubectl edit, you can also edit your YAML file using Vim, and then you can reapply. Okay. So now if you see here, the service is edited. Let's give it one more second for the service to get refreshed. I hope it is. So now let's take the same IP address one more time, and let's do curl followed by this. Okay. So I think it is taking a couple of seconds here. So let's give it a couple of seconds. Okay, so let us retry it. Okay, so if you see here, it just took a second because we gave the wrong labels and selector. I fixed the labels and selector. I went to the deployment file and I checked the labels and selector that we gave for the pod, and now it looks fine, right? So this is the thing. Like I told you, labels and selector is one of the most important things. So give your labels and selectors very appropriate, and it has to be like, in this case we just gave it as app demo, but when you're working in your organization, make sure that you give a valid and appropriate labels and selector. Okay, so now I'll show you what is the real advantage of the service. So now let's try to say that kubectl get svc. So this is my service IP address. Just remember this one. Now, as we did previously, I'll get the pod, and I'll show you the pod IP address that is currently allocated. -o wide. Okay, let's try to delete this one. Kubectl delete pod. Now you know that the deployment recreates and Kubernetes allocates a new IP address to this pod. Sometimes it might be the same IP address, but most of the times, the IP address gets changed. So let's see what will be the new IP address. And once you have the new IP address, I'll show you that how, if you use a service, your application is still reachable. So this entire concept in Kubernetes is called as service discovery. Okay, so one of the reasons why Kubernetes is quite popular is because of its service discovery, because of its scalability, and because of its high availability. Okay, now if you see here, the IP address is changed again, but we'll go to the Minikube cluster that we have, and we will rerun the same curl command. And if you see, the HTML page is populated, and it shows the same information. So this is the service availability feature in Kubernetes. Now, you might ask me that, so if service is doing everything, why do you have different service types, like, NodePort service type, cluster IP service type, and load balance service type? So as you have seen now, what I try to do is I logged into my Kubernetes cluster, and only people who can access the Kubernetes cluster, or only someone who can access the Kubernetes networking. So let's say your organization, you're on a virtual machine, and by VXLAN tunnel or any VLAN tunnel, it can access your Kubernetes network. So in such cases, it is fine. If you create a cluster FB service or a basic service that I've created, you can still access your application that is deployed in Kubernetes if you are connected through a tunnel, or if you logged into your Kubernetes cluster. But what if somebody who's sitting outside your Kubernetes cluster? Now, I am on my laptop. I don't have connectivity to my Kubernetes cluster apart from SSH. So in such cases, what I can do is that I can expose my Kubernetes service on NodePort mode. So if you expose your Kubernetes cluster, Kubernetes service in NodePort mode, basically your pod can be accessed, or your application can be accessed using the Kubernetes node IP address. So you need to understand in which node this pod is deployed, and using that node IP address, you can actually access, or you can, this is just for information, but you can typically access using any node IP address. That really does not matter, but that's a different discussion. So kubectl get, okay. So for your easiness, what I'll do is that I'll edit a service from the Vim itself. And what I'll do is that here I'll change this to type NodePort, and I'll grant a NodePort IP address as well. So what we can do is that, sorry, this is the syntax NodePort, and let's give a port that should be in the range of 30,000 to 32,000. So what I'll do is I'll give 31,000, and then I'll use the kubectl apply -f service dot YAML. So once this is applied, if you do kubectl get svc, the kube proxy, which is continuously monitoring everything, it allocates a node IP address. So this is your node port, and your application can now be accessed using the node IP address and followed by this port. So if I do minikube IP, I'll get the IP address of my Kubernetes node. It's a single node cluster that I've created. So it just has one node IP address. So what I'll do, I'll show you. Now I'm not logging into my Kubernetes cluster using minikube SSH, but if I access using node IP followed by the node port, what is wrong here? Okay, let me see what happened. So actually, we did something wrong. So initially we edited using kubectl edit, and then I applied Vim, but I did not cascade the information into Vim. So there were two labels applied to the service. Yeah, but okay, that really does not matter. If we go back to the demo, sorry. So again, let's do kubectl get svc. This is the NodePort IP address followed by this is the node IP. So let's say curl followed by this and 389. I just changed the service port, the node port IP address to see what was the issue. But the issue was different. Like I told you, the issue was with the labels that we have applied. Okay. So minikube IP. So this is the minikube IP address and followed by. Yeah, so it is actually good if things we do something wrong in the demo, because we can actually understand what we are doing wrong. And like one of the good experience from this is that initially I used kubectl edit and then I used VIM. So which shows that either you need to do it from Git, or you need to do a single process, like either edit everything from Vim and do kubectl apply, or use kubectl edit. So don't use the combination of both. Perfect. It was a good learning. Now the application can be accessed from the node IP address, which is our which is the goal that we wanted to see, right? So now you can access your application that is inside the Kubernetes cluster from outside, that is from your laptop or from your workstation. Now there is another possibility that, let's say your application needs to be accessed by a client who is not at all in your network. So forget about the Kubernetes network, but they're not at all in your network. So for example, now my minikube is also in my home Wi-Fi, and the laptop is also in the home Wi-Fi. So I can basically the both are in the same network, so we can access it using the node IP address. But what if somebody who is not part of my home Wi-Fi, or somebody who is not part of your organizational network, is trying to access, like you access Amazon.com every day, or you access Flipkart every day. So now Flipkart domain is completely different, Flipkart network is completely different, but you are still able to access it. So to do that, you can expose either your service using a load balancer type IP, which will not do now, because when you are on your on-premise, there is only one way of doing it, that is using metal LB, but we are not using it now for the purpose of demo. The other way to do it is by exposing or creating an Ingress resource. We'll try to do it very quickly. So we'll write a Kubernetes Ingress file as we did for the service. So go back and say Kubernetes Ingress. Okay. So this is your Kubernetes Ingress, and let's take a very basic example of Ingress as we are doing. Sorry for the messages. Okay, so let's quickly rename this one. For Ingress, you don't have to worry about the labels and selectors. K8s Demo and followed by, you can keep it or remove it. This is just an annotation for rewrite rule. And then Ingress class, just remove it. If you don't use any Ingress class, it will pick up the default one. If you want to know what is Ingress class, watch my video on Ingress in the Kubernetes playlist. For now, let's give the path as a very simple path. And let me also define a host for this. So let's take example that has host instead, right? Why should we basically waste our time? So let me simply delete everything and use the example that has host. Host. And let's say this as example test. Okay. And okay, for now, let's keep all of these things same. I don't want to waste your time. And the only thing that is important is the name of the service followed by the service port. I don't remember the service name. Let me quickly get that. kubectl get svc. Okay, so this is the name of the service, app demo. Okay, kubectl K8s Demo. Now let's save this one and create using kubectl apply -f ingress.yaml. So once you're done with this, there is an Ingress controller that is taken care. Like I already create an Ingress controller that you have to definitely do it, because your Ingress resource is something that is watched by Ingress controller. Like your pod is watched by Kubernetes deployment, Ingress resource is monitored by an Ingress controller, and this Ingress controller basically takes care of if it is deployed on AWS, it can basically talk to your AWS using Cloud Control Manager, and it can generate an IP address that is an external IP address. Using this external IP address, anybody can talk, because most of your Ingress controllers are load balancers, like Nginx Ingress controller or your FI Ingress controller, anything. So when you're doing it on your host, basically it generates the IP address. Like if you see kubectl get ingress, it might be created by now, and this is the IP address. If you see, this is the same as my minikube IP address. Okay, because I'm on my host, I'm not on cloud, or I'm not on any public cloud machine. So it generates the same IP address. But if you're doing the same demo on AWS, you can basically make use of Elastic Load Balancer, or you can make use of any Ingress controller which can populate an external IP address for you. So now, once I have done this, because we have provided the host name as example test, I should be able to access the application using example test HTTP. I mean HTTP followed by example test, but I'll not be able to do it. I know why. I mean, I'll tell you why, because we need to do a port mapping in the etc host. So I can simply say etc host so is the IP address same 64.3? Okay, perfect. So this is the IP address. What I'm basically doing is I'm mapping this IP address in my etc host to example-test. Once you do this, just give it a second, or sometimes it gets refreshed very quick. So if you see here, now I'm able to access completely outside my network. Okay, so you can basically try this examples, and for now I couldn't show you with a real-time public IP address, right? If it was a public IP address, so this is my minikube IP address, but if it was a public IP address, if you're on AWS or any other cloud provider, basically even you will be able to access my application that I deployed on my laptop in my Kubernetes cluster. Okay, so this is the demo, guys, and I hope you understood the concept of pod deployment, container, service, and ingress. If you still have any question, please put that in the comment section. Maybe I can make a detailed video on that. And don't forget to like, share, subscribe, and comment what is the next video that you're interested to watch on my channel. Thank you. I'll see you in the next video. Bye.